Hudi works end to end using a real world example. For this purpose, we have a self-contained data infrastructure running in a local Docker cluster within my laptop. Let's quickly take a look at it. As you can see here, we have like all the HDFS services, Spark and Hive services running, and we also have Kafka broker setup. Kafka is going to be the upstream data source from where we are going to pull in data, and the first step here, before we go to the first step, it's important to take a look at the data set. We are going to ingest stock tracker data at 1 minute granularity. We are going to ingest this to a Hudi powered data set, and this data set is going to have like for each stock ticker, the latest stock tracker data at 1 hour granularities. And we are going to ingest two batches of data. The first batch is going to have first 1 hour of trading window. The second batch is going to have the next half hour of trading window. This is intentionally set so that the second batch will have updates which are going to affect some of the rows brought in by the first batch. So the first step would be to upload the first batch of data to Kafka. And while this is happening, we can actually go to the Hudi CLI, which is the admin CLI provided by Hudi. And we can initialize a Hudi data set here. This is going to be a merge on read table, and which is going to initialize some HDFS directories. And let's see, the Kafka is broker is loaded with the data. Now, if you go in the name node web UI, you will see that there is an directory under stocktex, but the dataset is empty. So the next step would be to ingest the data from the Kafka source, and we are going to use a tool called Delta Streamer, and this tool will pull in data from the Kafka data source and ingest to the Hudi data set. Let's quickly run this command. This all the configurations provided here. This for like some of the configurations are connectivity information to Kafka broker, and it also have information related to the Avro schema and what a particular field is specifies the partitioning field and the primary key. That's the most of the configurations here. And once this is done, we have successfully committed one batch of data to the Hudi data set, which you can find it here. So as you can see here, there will be a delta commit, which means that the file, the commit was successful, and you will see a Parquet file getting generated, which contains all the data corresponding to first batch. Now the data is in the HDFS. We need to sync to Hive in order to run Hive queries, and the main tool to do that is a sync tool provided by Hudi, which can be run here, same place. So here, if you can see here, all we're doing here is we are passing the Hive server to URL along with the HDFS directory, which needs to be registered, and also the Hive table. So with once this is successful, we will see that so I have an Hive console open here, and if you see here, you will see the new tables that got added. There are two tables which are basically which are backed by the same Hudi data set that we have. The first table is represents the read optimized view of the Hudi data set. The second one provides the real-time view of the data set. So you can see here, you can see that there will be we'll use our own input format to filter out files that are not needed for scanning. And just also quickly we look at that the partitions are available, they are available. Now let's run a query. So this query is against the read optimized table, which will so the main purpose of this query is to for the Google stock tracker, what is the latest timestamp that I can see in the Hudi data set? This is going to be the first batch, which is 1029, because since this data is already there in the columnar format, the real read optimized view is able to retrieve that. And I'm going to run the same query with the real-time view, and I can also see the same. I can also see that it's reading the same data. Now let's upload the second batch of data to Kafka, and then let's go back and run the Delta streamer. This is going to ingest a new set of data here to the Hudi data set, and we should be able to see that there will be a log file that will be generated. Yeah. So you will see that the second batch of data did not merge with the existing Parquet file. Instead, it just log appended the merged data. And you can also verify that the commits are successful. There will be new commit file that got added. So now the Hive queries will diverge. You will see that on the real-time view, the same query, this will see that it will be able to read the log file also and do the merge, and we will see that the latest data is 1059, not 1029. But the read optimized view, which is will uh, will always go read the columnar data, which will have just a stale data. And so now that we have seen the diverge, let's see how to do compaction. So we'll go back to the Hudi CLI here and just confirm that there are no compaction. Now let's schedule a compaction. Yeah. So finally this got completed. So compaction got scheduled. So what that means is we will see a requested compaction metadata here with its own timestamp, and so connect again to refresh and look at the compaction show all. You will see that there will be a new compaction instant showing in this listing. So now the next step will be to run the compaction. This will merge both the logged changes and the Parquet file data in Parquet file and create a new version of columnar data. And once this is done, you will see that the Hive queries, even the read optimized query, will see the latest data. Okay, this has been completed. So you will see that this will be marked as committed, and you can look at the partition. You will see that a new version of Parquet got added. So then finally query. Same read optimized query. Now you will see that it will see the latest and latest data. That's it.